Relationship between SciPy and NumPy. SciPy appears to provide most, but not all, 1, of NumPy's functions in its own namespace. In other words, if there's a function named numpy.foo, there's almost certainly a SciPy.foo. Most of the time, the two appear to be exactly the same, oftentimes even pointing to the same function object. Sometimes, they're different. To give an example that came up recently, numpy.log10 is a ufunc that returns NaNS for negative arguments. SciPy.log10 returns complex values for negative arguments and doesn't appear to be a ufunc. The same can be said about log2 and lon, but not about log1p, 2. On the other hand, numpy.x and SciPy.x appear to be different names for the same ufunc. This is also true of SciPy.log1p and numpy.log1p. Another example is numpy.lineage.solve versus SciPy.lineage.solve. They're similar, but the latter offers some additional features over the former. Why the apparent duplication? If this is meant to be a wholesale import of NumPy into the SciPy namespace, why the subtle differences in behavior and the missing functions? Is there some overarching logic that would help clear up the confusion? 1. NumPy.min, NumPy.max, NumPy.abs, and a few others have no counterparts in the SciPy namespace. 2. Tested using NumPy 1.5.1 and SciPy 0.9.0 RC2.
Last time I checked it, the SciPy_init_ method executes a, so that the whole NumPy namespace is included into SciPy when the SciPy module is imported. The log10 behavior you are describing is interesting, because both versions are coming from NumPy. One is a ufunc, the other is a numpy.lib function. Why SciPy is preferring the library function over the ufunc, I don't know off the top of my head. Edit. In fact, I can answer the log10 question. Looking in the SciPy_init_ method, I see this. The log10 function you get in SciPy comes from numpy.lib.simath. Looking at that code, it says, it seems that module overlays the base NumPy ufuncs for sqrt, log, log2, lon, log10, power, arccos, arcsine, and arctanh. That explains the behavior you are seeing. The underlying design reason why it is done like that is probably buried in a mailing list post somewhere.
From the SciPy reference guide. All of the NumPy functions have been subsumed into the SciPy namespace so that all of those functions are available without additionally importing NumPy. The intention is for users not to have to know the distinction between the SciPy and NumPy namespaces, though apparently you've found an exception.
It seems from the SciPy FAQ that some functions from NumPy are here for historical reasons while it should only be in SciPy. What is the difference between NumPy and SciPy? In an ideal world, NumPy would contain nothing but the array data type and the most basic operations: indexing, sorting, reshaping, basic elementalized functions, etc. All numerical code would reside in SciPy. However, one of NumPy's important goals is compatibility. so NumPy tries to retain all features supported by either of its predecessors. Thus, NumPy contains some linear algebra functions, even though these more properly belong in SciPy. In any case, SciPy contains more fully featured versions of the linear algebra modules, as well as many other numerical algorithms. If you are doing scientific computing with Python, you should probably install both NumPy and SciPy. Most new features belong in SciPy rather than NumPy. That explains why SciPy.Lineage.solve offers some additional features over NumPy.Lineage.solve. I did not see the answer of Seth Morton to the related question.
There is a short comment at the end of the introduction to SciPy documentation. Another useful command is source. When given a function written in Python as an argument, it prints out a listing of the source code for that function. This can be helpful in learning about an algorithm or understanding exactly what a function is doing with its arguments. Also, don't forget about the Python command dir, which can be used to look at the namespace of a module or package. I think this will allow someone with enough knowledge of all the packages involved to pick apart exactly what the differences are between some SciPy and NumPy functions. It didn't help me with the log 10 question at all. I definitely don't have that knowledge, but source does indicate that SciPy.Lineage.solve and NumPy.Lineage.solve interact with LPACK in different ways. This is also my first post, so if I should change something here, please let me know.
If you want to see more, press the consider subscribing.